All right, so your final is going to be on Tuesday. It's going to be 11 or 12 questions, and a little bit less than half of them will be multiple choice, and the rest will be free response. So super similar to what you saw in the quiz. The only difference is that we're adding 10.5 as well, which is the permutations and combinations. So let's look at 10.1. Last season's basketball uniforms were stored in 2 boxes. One box contains 15 numbered jerseys, the other contains the matching numbered shorts. Your coach tells you to grab a jersey from one box and a pair of shorts from the other box. All 15 players grab a jersey from the first box. You are the first one to reach into the box of shorts. You grab the first pair of shorts you touch. How likely is it that you will grab the number that matches your jersey? So we have 15 shorts total. So it would be 1 out of 15 because there's only one that matches the number jersey. Number 1 in the next section, tossing a coin 3 times. What's the probability you get 1 heads and 2 tails? So we have, in our first toss, 2 possible options, heads or tails. Second toss, we have 2 possible options, heads or tails. Let's say we flipped heads the first time. Second toss, we could either have heads or tails. So that's 2 tosses there. Third toss, we could get heads or tails, heads or tails, heads or tails, heads or tails. So each row here is like 1 toss of the coin. So this would be 1 toss. This is another toss. This is another toss. So this are 3, all of our possible outcomes when we flip the coin 3 times. Now we could write all of our possible outcomes by just going up here. So if we went up this row, it would be heads, heads, heads. If we went up from here, it would be tails, heads, heads. We could write them all out if we wanted to, but we don't have to. It just says what's the probability to get 1 heads and 2 tails. So here we have 1 heads and 2 tails. Right here. And then here we have 1 heads and 2 tails. And here we have 1 heads and 2 tails. So that would be 3 out of 8. So there's 8 different possible outcomes when you flip 3 coins, and 3 of those gives you exactly 1 heads and 2 tails. Another way we could find all of the possible outcomes is that when we flip a coin 1 time, our 2 possible outcomes, or I guess we have 2 possible outcomes, 2 total, if we flip a coin once. 2 possible outcomes. So that's just flipping it once. If we flip it another time, we have another 2 possible outcomes, that's either heads or tails. If we flip it another time, we have another 2 possible outcomes, which are heads and tails. If you multiply these 3 together, so you're multiplying the 3 flips, all the outcomes in each flip, that would give you 8. So we have 8 possible outcomes total, which is, again, how we got that denominator 8. So you can always multiply how many different possible outcomes for each event to get your total possible outcomes. Or you can just draw the tree like we did here. So number 2, spinning a spinner twice that contains 4 equally likely colors, blue, red, yellow, green. What's the probability that you land on red twice? So we can draw our tree. So we have blue, red, yellow, green. This is just 1 spin because each row counts as 1 spin. We can have another spin here just by drawing our tree. So the next spin, if we did blue the first time, would it be blue, red, yellow, green? If we did red the first time, landed on red the first time, our next spin could be blue, red, yellow, green. If we landed on yellow the first time, our next spin could be blue, red, yellow, green. And then if we did green the first time, blue, red, yellow, green. So counting all of our possible outcomes here, we would have 16. And the question asks, what is the probability you land on red twice? So the only one that is red twice is right here. So that is just 1 out of 16. Number 3, spinning the spinner mentioned in exercise 2, followed by tossing a coin. So in the answer key, I had it as if you spun the spinner twice, like here, and then you flipped a coin after that. But I think the wording would be if you just spin like the spinner once and you toss a coin. So if there was a question like this on the test, it would be more explicit on how many times you're spinning the spinner. But let's just say we spin it once. We have blue, red, yellow, green are possible outcomes, and then we toss a coin. So 2 possible outcomes for each toss. We could have heads or tails, heads or tails, heads or tails, heads or tails. So counting all of our possible outcomes, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. And that's just what this question asks. No probability here. Another way we could have done this one is spinning the spinner. We have 4 different outcomes. It could be blue, red, yellow, or green, so 4. Tossing a coin, we have 2 different outcomes, heads or tails. So 4 times 2 would be 8. So 8 possible outcomes. Same thing, just 2 different ways of doing it. Again, the answer in the answer key is a little bit different because I had that one as spinning the spinner twice, but I think we're only supposed to spin it once. Let's go to the next page. So again, we're sticking with 10.1, just more questions on finding the possible outcomes. You roll a die and draw a token at random from a bag containing 3 pink tokens and 1 red token. So we roll a die. There's 6 possible outcomes when we roll a dice. And then when we draw a token from the bag, it could be one of the 3 pink ones or one of the red ones. So that would be 4 total. So we have 6 times 4, which would be 24. Number 3, when 2 6-sided dice are rolled, there are 36 possible outcomes. Find the probability that the sum is 5. So here I included the little picture of all of our possible outcomes when we roll a 6-sided dice. So find the probability that the sum is 5. We have the sum of 5 here, 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 and here. So that would be 4 out of our total 36, which 4 out of 36 simplifies to 1 over 9. And again, for all of these probability questions, you can leave your answer as a decimal or a fraction or percent if you want. Find the probability that the sum is not 5. So these are 4 where the sum is 5. So if 4 of the total are 5, that would mean 32 out of the 36 are not 5. And then we can simplify this to 8 over 9. Find the probability that the sum is less than or equal to 5. So these are all the ones that are equal to 5. Less than would be these as well. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36. Which this simplifies to 5 over 18. Find the probability that the sum is less than 5. So that would be 1, 2, 3, 4, 5, 6. 6 out of 36. Which is 1 over 6. Number 4 deals with our geometry and area type questions. So a tire is hung from a tree. The outside diameter is 34 inches and the inside diameter is 14 inches. If you throw a baseball towards the opening of the tire, your baseball is equally likely to hit any point on the tire or the opening of the tire. What is the probability that you throw the baseball through the opening of the tire? So we have our outside diameter, or our outside circle, and then our inside circle. So the outside diameter is 34. The inside diameter is 14. Okay, not drawn to scale, but it's fine. So our total area We find that by pi r squared. If our diameter is 34, our radius is half of the diameter, so that would be 17. So 17 squared times pi, which would be 289 pi, or we could just multiply it all together, and that gives us 907.46. So that's the total area of the whole thing. All of this. The whole big circle. Now, it's asking us what's the probability that you will throw the ball through the opening of the tire. So that would be in here. This circle. So we want to find the area of the little circle now. Again, we use pi r squared. Our diameter of the little circle is 14. So that would mean the radius of the little circle is 7. So we have 7 squared times pi, which is 49 pi, or 153.86. So we always put what we want over the total. So we want it to go through the opening, which is 153.86, over the total area, which is 907.46. Divide that in our calculator, and we get 0.1695. For number 1. The next number 1, I guess there's a lot of those. You roll a die and flip 2 coins. So when we roll a dice, we have 6 possible outcomes. When we flip a coin, we have 2 possible outcomes. And we flip the coin twice, so we multiply it by another 2. So 6 times 2 times 2 would be 24. Number 2, you draw 2 marbles without replacement from a bag containing 4 red marbles, 2 yellow marbles, and 5 blue marbles. What's the probability you draw 2 yellow marbles? So here, we draw drawing 1 marble out of the bag. It could either be one of the 4 red marbles, 2 yellow, or 5 blue. So we have 4 plus 2 plus 5, which is 11. So 11 possible outcomes. And then the key word here is without replacement. So once we pick that 1 marble out of the bag, we're not putting it back into the bag. We keep it out of the bag. So the next time you pick a marble, there's only going to be 10. So 11 times 10 is 120. 110. Oops. So we have 110 possible outcomes. Now we can draw our tree with all of these possible outcomes and then see which one has yellow and yellow, and that would be our probability, however many would go on top of the 110. But another way we could do this, a little shortcut, is out of the 11 marbles, 2 of them are yellow. And we took 1 out, so we picked a yellow one the first time. Because what's the probability you draw 2 yellow marbles? We're saying we drew a yellow marble the first time. That means that there's 1 less yellow marble in the bag because it's without replacement. We didn't put it back. So that would mean that there's only 1 out of the 10 left. So we just multiply the tops together just like we did the bottoms. So this would be 2 out of 110. The answer key looks a little bit different for this one just because I did not see without replacement when I was working on this for the answer key. So if it was being replaced, that's the answer in the PDF, but you won't have one like this on the test. So there won't be one that's tricky like this. Number 4, a bag containing 8 black cards numbered 1 through 8 and 6 red cards numbered 1 through 6. You choose a card at random. What's the probability you draw a card with the number 6? So we have 1 through 8 black cards and 1 through 6 red cards. That means we have 14 cards total. And out of those 14, there's a red one with the number 6 and a black one with the number 6. So 2 out of 14, which is 1 out of 7. We don't have to multiply anything here just because we're only picking 1 card. All the others we had like drawing 2 marbles, flipping a dice and a coin, like multiple things going on. That's why we multiply. This one, we're just picking one card, and that's it. Number 5, you draw a number card from a standard deck of cards. What is the probability that you draw a face card? This one, again, a little tricky just because you have to know how many cards are in a deck and how many face cards you have. So there's 52 cards total in a deck. And face cards are Jack, King, and Queen. Jack, Queen, King. And we have 4 for each suit, so that would mean we have 12 face cards. And we can simplify this. 4 goes into 12 and 52 3 times, so 3 out of 13. 4 goes into 12 3 times and 52 13 times. So this is our answer. Next, in a classroom of 20 students, 12 students have brown hair, 4 students have blonde hair, 3 students have red hair, and 1 student has black hair. Find the probability of randomly selecting a blonde-haired student from the classroom. So we have 4 blonde students out of 20 students total. So that would be 1 out of 5. Next page. First, we want to complete the two-way table and then answer our questions. So this number plus this one equals 33. So that would mean that missing number there is 5. This number plus this number equals 22. So that missing number here would be 14. We can add these two together to give us the total here, which should be 42. We add these two together, which gives us the total here, which is 18. Nope, 13. It said 18, but wrote 13. And then we can either add these two together or we could add these two together, but you don't want to add them all together. So 33 plus 22 is 55. So that's our total. Now, what is the probability that a female driver started driving younger than 16? Whatever it says first, that goes on the bottom. So a female driver, we have 22 female drivers total. So 22 is going to go on the bottom of our fraction. Out of those 22, 14 started driving when they were less than 16. So 14 out of 22, which simplifies to 7 over 11. So just remember, whatever it says first goes on the bottom. What is the probability that a driver started driving when they were older than 16? So this one, it just says a driver. So that's all of our drivers total. So 55. Older than 16, this one's greater than 16, so that would be 13 people total started driving when they were older than 16. Doesn't matter male or female. This question says nothing about male or female, so we just look at how many people total. All right, number 1 on the next section, we have to do the same thing, fill in the chart. So this is 112, 151, 158, 282, and 19. What is the probability that a teacher ran the half marathon? So it says a teacher first, so we look at how many teachers total we have, which is 158. Ran the half marathon. So ran the half marathon, yes, would be 7 out of 158. Next question, we're moving on to the next chart below. So we would have 85 here, 141, 34, 131 here, and 95. So this question says, if a person is chosen at random, what is the probability that they have a dog? So we're choosing a random person, doesn't matter if they have a cat or not. So their total is 226. What is the probability that they have a dog? So all the people that have a dog, it's 95. So 95 out of, own a dog would be, yes, here, 131. So 131 out of 226. We could simplify this fraction if it can be simplified, or you could always just leave it as a decimal, because that way you don't even have to worry about, can this be simplified? Just put it in your calculator, divide it, give me the decimal. B, if a person owns a dog, what is the probability they do not have a cat? So if a person owns a dog is going to go on the bottom. So yes, they own a dog, 131. What is the probability they do not have a cat? Out of the 131 people, 107 do not have a cat. So 107 out of 131. And that's 10.3. On to 10.5. So in exercise 1 through 3, which is just 1 and 3, find the number of ways that you can arrange all of the letters and 2 of the letters. So first, you want to look at all the letters. One keyword that you'll see here is arrange. Arrange means that it is a permutation. So here we're arranging all 5 of the letters. We're not like picking a certain amount, so it's just 5 factorial, which is 120. For the next one, we're just asked to pick 2 of the letters. So that would be 5 factorial over 5 minus 2 factorial, which would be 5 factorial over 3 factorial, which if we multiply the top, it's 5 times 4 times 3 factorial. The 3 factorial is going to cancel out with the 3 factorial on the bottom. So 5 times 4 is 20. For the next one, we have wonderful. So there's 9 letters total. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 9 factorial would be if we're arranging all of the letters. So that would be 362,880. And then just arranging 2 of them, we could say 9 factorial over 9 minus 2 factorial. Because this is a permutation. So 9 times 8 times 7 factorial over 9 minus 2 is 7. So the 7 factorials cancel. 9 times 8 is 72. So anytime you see the word arrange, it means that it is a permutation. I'll write the little formulas up here for you guys for permutations. So that's NPR. N always comes first. The bigger number is always going to be your n, and that's going to go on top. So n factorial over n minus r factorial is for permutations and combinations. Again, you have n and r. N is always going to be the bigger number, and it's always going to come first. So we have n factorial over n minus r factorial times r factorial. So permutations and combinations. I'll also write a few keywords for permutations here. If it says arrange, sorry, my handwriting is so bad. My pencil's not working. So if it says arrange, it's a permutation. If it says different, permutation. If it is like a race for first, second, and third. If it's an election for different things. Or if it's anything that the order matters. So, order matters. Then it is permutation. So these are just some common types of permutations. In combinations, it'll either say like how many combinations, or it'll say like how many groups. So groups is just a general term for combinations. But sometimes the question could say how many combinations, possible combinations here, so you know you're using combination. So for number 10, you have textbooks for 7 different classes, and how many different ways can you arrange them together on your bookshelf? So arrange, it says different and arrange. So this we know we're going to use permutations, and we have 7 different classes, and we're arranging, 7 different textbooks, and we're arranging all of the textbooks. So this would just be 7 factorial. So it'd be 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040. I know I skipped 4 through 9, but these are just the formula. One mistake that I made when doing the answer key is in number 6. 10 is our n, so we have n factorial over 10 minus 7 factorial. In the answer key, I had 10 minus 3. I just kind of got ahead of myself there. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. Because 10 minus 7 is 3, so this would be 3 factorial on the bottom. So the 3 factorials cancel, and then I just have to multiply. 10 times 9 times 8 times 7 times 6 times 5 times 4. And that would be 604,800 as our answer. So a little bit different than the answer key just because I messed up. That happens. For 4, 7, and 9, we just use the formula here. So in number 12, we have to count the possible combinations of R letters chosen from the given list. Combinations means we're using combinations to this formula. So we have 1, 2, 3, 4, 5, 6 letters total. So 6 factorial over 6 minus our R is 2. So 6 minus 2 factorial times 2 factorial. So running out of room, I'm going to do it on the side over here. This is 6 times 5 times 4 factorial over 6 minus 2 is 4 factorial times 2 factorial, which is just 2 times 1, so just 2. 4 factorials cancel. 2 cancels out 2 from 6, which we'd be left with 3. So our answer here would be 3 times 5, which is 15. Right, 13 is the same thing. I'm going to look at 15 because it's a little bit different. So again, we're using our formula for combinations. We have 7 factorial over 7 minus 7 factorial times 7 factorial. So 7 factorial over 7 minus 7 is 0. 0 factorial is 1. So we can just cancel that out because it's like 1 times 7 factorial. Then we're just left with 7 factorial over 7 factorial, which cancels out to be 1. So our answer for 15 is just 1. All right, in 20 and 21, we have to tell whether it's a permutation or combination and then answer the question. 95 triathletes are competing in a triathlon. In how many ways can 3 triathletes finish first, second, and third place? So order matters because it's different first, second, and third place. So we have 95 athletes. Since order matters, it's a permutation. And there's 3 places that we care about. So it would be 95P3. And then I trust that you guys can solve from here, or you can just look at the answer key. 21. Your band director is choosing 6 seniors to represent your band at the band convention. There are 44 seniors in the band, and how many groupings can the band director choose 6 seniors? So we have 44 seniors total. Groupings tells us that we're going to use combinations, and we're choosing 6. So 44, choose 6. And then we can just plug 44 and 6 into our formula. Multiply it all out. Next page. 20. You and your friend are ordering 3-topping pizza. The pizzeria offers 8 different pizza toppings and how many combinations? So be careful here because even though it says different's talking about the pizza toppings, not the order or the pairings of them. So it says how many combinations of 3 pizza toppings are possible. So this is a combination. 8, choose 3. We have 8 total and we're just picking 3 of them. 21. On a biology lab exam, there are 8 stations available. You must complete the labs at 6 of the 8 stations. In how many ways can you complete the exam? The order doesn't matter for this one, so we have 8 stations total, and we're only picking 6. 22, your committee is voting on their logo. There are 7 possible logos, and you are to rank your top 3 logos. And how many ways can you rank the top 3? So here we're just ranking the top 3. It's not first, second, and third. We're just grouping the top 3 together. So this is actually a combination. So 7, and we're picking 3. Last question, number 15. A random drawing will determine which 3 people in a group of 9 will win concert tickets. What is the probability that you and your 2 friends will win the tickets? So this one is probability. Anytime it says probability and it's like the permutation or combinations types of questions, it's going to be combinations. You will not have to find probability of a permutation. So anytime it says probability, you're using combinations. So there's 9 people total, and we're choosing 3. Careful here because which 3 people in a group of 9, then it says you and your 2 friends, so some people will get confused and just think that you're picking 2, but it's you and 2 friends, so that's still 3 people. So you're 9 people total, only 3 are getting picked. So this would be 9 factorial over 9 minus 3 factorial times 3 factorial. So 9 factorial is 9 times 8 times 7 times 6. 9 minus 3 factorial is 6 factorial times 3 times 2 times 1. 6 factorials cancel. 3 can take out 3 from 9, and we're left with 3 there. 2 can take out 2 from 8, and we're left with 4. So 3 times 4 times 7 is 84. And since it says probability, you and your 2 friends are just one group out of the 84 possible groups here. So that would be 1 out of 84. So anytime it says probability, you're using combinations, and at the end, you just put 1 over whatever combination you got. So I know for these types where you had to pick if it's combination or permutation, I didn't work them out, but they are worked out in the answer key. So if you have questions on those, just take a look at the answer key. Remember, test is Tuesday. If you guys have any questions, feel free to email me or ask me during class on Monday. Bye, guys.